Hello and welcome to fresponse.com. Today we're going to talk about fresponse Collect, our client-server tool for collecting remote disks, volumes, and profiles. fresponse Collect is a client-server tool. We have our Windows client here that's on our Examiner machine and a server out on the internet. This is our fresponse Collect server. We're going to go ahead and double-click on that server that we've added and connect to it, and then we'll go through the process of talking about how we would get the Collect software on a subject machine. We'll go ahead and show you what it's like to export an MSI. Again, fresponse Collect is all about allowing you to have remote subjects collect data, either disks, volumes, or profiles, to the Collect server suitable for review and analysis. Creating an MSI for fresponse Collect is rather straightforward. You can set all of the following settings on your own, including the time the subject should wait before checking in to determine if it's needed in a collection task. We're not going to export an MSI today because we've already done that, and we've got Collect running on a number of remote subjects. So let's go through the process of creating a collection. Specifically, we're going to create a disk collection today. First thing we'll do with the wizard is set the collection name. In this case, we'll just call it Test Collection and move to the next frame. The subject we'll select next. We'll select this 64-bit Windows 10 subject and add it into our list of subjects to be collected. From there, we'll select a target. The Windows 10 subject allows us to collect either profiles, physical disks, or physical volumes. For the sake of expediency today, we'll go ahead and select Disk 2 and add that into our collection. We'll press Next and move to the final frame of the wizard where the collection wizard will ask us to confirm all of the steps. We have the proper Collect server, the name, the subjects, and the device we want. We'll go ahead and hit Finish, and it'll create the collection on the server. That collection has a single subject, and that subject has a single device. On the remote subject, periodically, based on that wait hinted interval, that interval of check-in, the subject will reach out to the server, see that it's needed in a collection, and begin performing the actual operation. In this case, what it's done is it's spawned a second process and begin collecting data from disk 2 and pushing it up to the server. Since this is simulating a collection operation over the internet, we want to make sure we simulate what would happen in the loss of connectivity between the subject and the Collect server. So what we'll do is we'll drop from this Examiner machine to the subject machine itself and try to simulate what that would look like. Here we are on the subject machine. We've got access to the network interface. We're going to right-click and disable that interface. Again, the idea is to sort of make this look like what might happen in the event that the end user maybe shut their screen down, close the display, reboot, etc., move to a different network. So here we can see the machine is disabled. If we were to return to the Examiner display, we'll notice that our fresponse image operation has stopped at roughly 10%, and we haven't gotten a last seen update in a little bit of time, which makes sense. The subject is offline and unavailable to connect to the server. So what we'll do is we'll return to the subject and we'll re-enable the network interface. Now it's important to note when we do this that we're not restarting or doing anything to the fresponse subject software. It's designed to pick up on its own, reach out to the server, and resume within roughly 10 megabytes of where it left off. So what we'll do is we'll wait here for a second and then we'll return to the Examiner machine and we'll look at where we are in the process. If you'll recall, we stopped at roughly 5 to 6%, and here you can see we're over 14% and climbing. So essentially what we're able to do is resume an image operation within 10 megabytes of where we left off in the case of any loss of network connectivity or the like. So we'll go ahead and stop the video now and return to the video after we've completed this collection. Alright, so here you can see after we've completed the collection, the imaging has reached 100%, that subject's task is complete, and the overall collection is complete. You can see we have an image file that resides at the server. It's a RAW or a DD style image. We can right-click and download this image to our local machine where we could perform analysis on it, review, or use other tools to convert it into a different imaging format. I'll go ahead and save it to a collection folder I have designated on my machine for exactly that. Downloading that image file may take a reasonable period of time depending on how large it is. That operation may be resumed. If for some reason you lose network connectivity, as long as you haven't deleted the actual image file, you can always right-click and resume or pick up the download where you left off. So this gives you an overview as to what fresponse Collect allows you to do. It gives you a robust mechanism for collecting physical devices, volumes, and profiles, and doing it in sort of a tool and vendor-neutral manner over the network. is designed for resumability and robust operation. You can learn more about F-Response Collect at www.f-response.com. Or if you have specific questions, send us an email at support@f-response.com or sales@f-response.com. Thanks, and have a great day.